People say AWS is expensive, but that is almost never the real problem. AWS pricing is actually very predictable. The cost of Lambda is predictable. The cost of storage is predictable. The cost of network traffic is predictable. What makes cloud systems expensive is not pricing, it is architecture. Cloud cost is not a pricing problem, it is a composition problem. Modern cloud platforms encourage abstraction. Instead of managing infrastructure directly, we compose systems from managed services. Lambda, API Gateway, Event Bridge, Step Functions, DynamoDB. Each of these services is individually inexpensive, which creates the illusion that building systems from many small services will also be inexpensive. When engineers look at pricing tables, every component appears cheap. A few milliseconds of Lambda compute, a few million events in Event Bridge, a few thousand API requests. Individually, these costs are almost invisible. But systems are not built from individual services. Systems are built from compositions. And composition changes everything. Because once services start interacting, cost is no longer tied to infrastructure. Cost becomes tied to system behavior. A typical modern architecture might look like this. Requests enter through API Gateway. They trigger Lambda functions. Those functions publish events. Events trigger other functions. Workflows coordinate additional processing. Each layer is designed to simplify development. But every layer also increases the number of possible interactions. And this is where cost begins to grow. Every service interaction introduces new work, serialization, network transfers, retries, logging, event propagation. Individually, these are tiny costs. But when they occur across thousands or millions of interactions, they multiply. This leads to a fundamental misunderstanding about cloud systems. Engineers assume cost comes from compute resources. But in distributed systems, cost often comes from communication between components. The Lambda invocation might be inexpensive, but the retries are not free. Network hops are not free. NAT gateways are not free. Data serialization is not free. And idle waiting inside workflows is definitely not free. Most cloud cost is indirect. This behavior is very different from traditional infrastructure. In CAPEX environments, organizations purchase hardware up front. Servers run continuously. Storage is already provisioned. The cost is mostly fixed. Once the hardware exists, inefficiencies are absorbed by the system. In these environments, infrastructure creates cost gravity. Workloads run on machines that already exist. Abstractions do not significantly change cost. The hardware absorbs the inefficiency. Cloud systems behave very differently. Infrastructure is not purchased once. It is activated dynamically every time the system interacts. Every event, every request, every message creates new infrastructure activity, which means the cost model becomes interaction dependent. Now combine retries, serialization, network hops, and cold starts. Each one multiplies the others. A single user request might trigger dozens of service interactions, and each interaction creates new cost events. This is why some of the largest cloud bills come from unexpected places. NAT gateways, excessive retries, chatty microservices, event storms. The system becomes economically unstable even though every individual service looks cheap. This reveals an important systems principle. Cost does not emerge from components. Cost emerges from structure. The topology of your architecture determines how interactions propagate, which creates an architectural paradox. Some designs that are perfectly reasonable in on-premise systems become extremely expensive in the cloud, because abstractions that were once free now generate infrastructure activity. In other words, abstraction layers amplify structural inefficiencies. Small inefficiencies become exponential cost behavior, which means the real optimization problem is not infrastructure tuning, it is architectural composition. The most effective way to reduce cloud cost is to reduce unnecessary interactions inside the system. If you want to understand your cloud costs, do not start with pricing calculators. Start by mapping system interactions. Identify where abstractions multiply communication paths. Because in distributed systems, cost does not scale with traffic alone. It scales with architecture, and that is systems thinking for architects. Understanding systems before the invoice explains them.